All right, chapter 3 review. So solving systems of equations and also systems of inequalities. And we're going to review all that in this video. Normally I play a game in class, but obviously through distance learning, it's kind of tricky to play this game. But just have pencil, paper out, calculator, and do the questions as we go through them. So first one, again, pause the video, try it. Hopefully at this point you have a pretty good grasp of the different methods and stuff. On the test, you can pick whatever method you want, except there is one where I think you have to graph, but otherwise you can pick. So we'll do one graph one here in a second, but for this one you can pick. Okay, so you could actually use substitution pretty easily. You could add 5y to both sides to get x alone. But when they're both in standard form, the combination method is going to work super well. So especially in this case, because I have a single x here, so if I just go times 2, then I'll have negative 2x and positive 2x. So I'm going to take the top one, make sure you do all the parts times 2. Oftentimes students forget one part, but take all of it times 2. Bottom equation stays the same. Okay, and then we just add these together. And the x's disappear, the y's disappear, and actually we get 0 on this side too. So when that happens, you just got to remember that's our infinite solution. If we get where they aren't equal, if you get like 7 equals 0, then it's no solution. All right, but if the two sides are equal, then it's infinite solutions. All right, so try at least one graphically, right? Because you have to do at least one graphically on the test. So the key is you have to draw them really accurately because the solution is where they cross. So generally graph paper will help, or something like Desmos or graphing calculator. All right, so graphing this first one, we're going to start at negative 5 and have a slope of 2. And because it's got to be so accurate, I'm just going to draw a bunch of dots. Right, I'm going up 2, right 1 each time. And drawing dots. Okay, and then see which dot they have in common. So this one's going to start at positive 3 and have a slope of down 2, right 3. And so I've already got the point where they cross. Right, so it looks like they're going to cross and meet right here. So that's the point 3, 1. So our solution in this system is x3 and y1. That's the xy point that works for both of those two equations. That usually goes well on the test as long as you just draw them accurately. And slope is usually the biggest problem. So like this one has a positive slope, right? So make sure it's going uphill as you go left to right. And then this one has a negative slope. The red one has a negative slope. So make sure that one's going downhill as you go left to right. It's an easy way to check to make sure it goes okay. All right, picking a method again. Set up pretty well for substitution because we have x alone in the second equation. So we're just going to substitute it in up here. So we have 9, and then we're going to take out x, just like you might take out a player in basketball and replace him with somebody else. So that's the top equation. But now x, we're replacing it with 12 minus 2y, right? And now just solve this for y. So we're going to distribute here. 9 times 12 would be 108, I believe. Minus 18y minus 5y equals negative 30. And then let's see, combine the two like terms there. So negative 23y minus 108 from both sides. So negative 23y equals negative 138. And divide by negative 23. And we should get 6 there as our answer. All right, and so we're not done yet, right? That's just the y part. So to find the x value, plug it back in, and we're going to have 12 minus 2 times 6. So x is going to be 12 minus 12, or just 0. So we have x0, y6 as our solution. All right, another one, solve using any method. All right, set up good for substitution. So this can go right here for x. So we'll have, we had a single x there, so we'll have -2 minus 3y, right? And sometimes, oftentimes you distribute. So if you want to put that, it's 1x there, you can. But that's the x part, and then plus y equals 2. And then the 1 really doesn't do anything, right? You just have a single x, so it doesn't really do anything. Now combine like terms, so -3y, positive 1y. Add 2 to both sides. Divide by -2. Okay, and we're halfway there. We can use whatever equation we want, but this one's already solved for x, so it's probably going to work pretty well. So do -2 minus 3 times -2. A lot of negatives there, but -2 plus 6, negative times negative, so x is going to be 4. So our solution is x4, y, -2. All right, last one, the solve any method type. That's the main thing, is to be able to solve systems of equations, and then we'll kind of, I think, transition to inequalities next, or maybe a story problem. I can't quite remember. But at any rate, give this one a shot. X and y are on the same side for both equations, so the combinations method will work pretty good. Combinations or elimination. I'm just going to take this one times 2 so that the x's will cancel. So the top one I'm rewriting, just everything is doubled. And the second one, we're going to leave the same. Add these together. And the x's cancel out, gives you 0. The y's cancel out. And then this side we get 7. So again, this is just a special case when both x and y cancel. And now we have a statement that's never 2. 0 is never equal to 7. So this is a system that has no xy pairs, right? So if we were to graph these, they would make a parallel line, parallel lines, and they would have no points in common, no points that they share. All right, so an inequality question, right? So what's different for inequalities, we only have one method, the graph method. We have to graph them all and find where their shading overlaps, right? So pause the video, give this one a shot. Okay, so the top one here, x plus y less than or equal to 8, we want to get y alone. So I'm going to minus x from both sides and then graph the line. So it's going to start at 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's starting kind of up high here. And then I'm going to go down 1 over 1. All right. And sorry I can't draw lines super good on here, but we'll connect them. That's actually not too bad. And actually, I kind of forgot. Remember on these, I should always check before I draw the line. So if it's an equal to, you're going to draw a solid line. If it's not an equal to, you're going to draw a dashed. And then the shading part is if the mouth is facing y, that means y is big. So we're going to go above the line in that case. And then if it's facing away from y, means y is little, and we go below. So on this one, it's facing away from y. So I'm just going to make a mental note that I got to shade below this line. Sometimes I lightly shade and then darken it in later, but that's hard to do on my little file here. Okay, next one, right here. I'm going to get y alone again, so minus 2x. So we just have minus 2x on this side. 0 minus 2x is just negative 2x. And then divide by -1. So we're going to divide both sides by -1, and that's going to flip the sign. Anytime you multiply or divide with a negative, it flips. So this one's going to start at 0, have a y-intercept of 0, and a slope of 2. So up 2, right 1, positive slope. Going to be a dashed line this time because there's no equal to. All right, and we are shading below it again. The mouth is facing away from y, so we're going to shade below. All right, and then our last line is this a special case. And so if it's an x line, it goes up and down. So it's kind of goofy because the x-axis goes horizontally, but this is going to go vertical. So I'm going to go to -2 on x. It's going to be a solid line up and down. That's where x equals -2. And we want to be greater than that. So we're going to go this way from that line. Okay, so I probably should have extended the blue line out. But at any rate, we want to find where all of these converge, right? And so I'll draw this as best I can. But that's going to be over here. So where they all overlap is below those two blue and green line, and then to the red line we have to be to the right of it, right? Because we're greater than or equal to -2, so we're going to go that way from -2, right? So that yellow region is our solutions here. All right, same type of question, just different graphs, right? So these are kind of different graphs, and be careful when you're graphing them. Think through, is it a line, a V, is it a horizontal line, vertical line? It could be any of those things. All right, so first one, we're going to go to 4 and then draw a dashed line. That's y equals 4, but we have no equal to, so it's a dashed line. And then we're below that, so y is little, right? So we're shading below that line, less than 4. All right, and then on the second one, this one's going to be a v, right? Because of the absolute value, it's going to be a v. So I'm going to go right 3 because of this -3 and up 2. And again, that's not the slope. That's just where the v starts, right? Absolute value is a v, and normally it starts at 0, 0. But this one's going to start at 3, 2. It's going to start right there. Okay, and then the slope is actually the number that's in front, which in this case, the number right here is a 1. So we're just going to draw a dashed line again, and it's going to have a 1-to-1 slope going in both directions. So it's up 1 over 1 slope. All right, and we are shading above that. The mouth is facing y, so we're going to be above the v up here. Okay, and so where they overlap ends up being this little green region, kind of like a pizza slice region right there. All right, and that is the solution to that system of inequalities. Okay, the last type of question I want to do here is the ones where you have to like minimize or maximize a function. And just to save some time, here's our set of constraints, a bunch of inequalities, and you just graph them, right? So just like we did on the previous question, you're just going to graph them, and it's kind of hard to see, but they overlap in this middle triangle here. Okay, so once you do that, you'll get like a shaded region, and then you're going to take the vertices. So the vertices for this one, they're really hard to see. Sorry, this is x -1 and y 2. This one is x 0, y 1. And this one is x 0 and y -2. Okay, so see if you can remember, what do you do from there, right? We graphed them, we found the vertices, and what do you do from there? So this is minimize or maximize a profit function. So from here, we're just going to plug them in, each xy pair, and figure out what gives the, let's see, we want minimal profit. I don't know why I want minimal profit. Maybe it's something else. But at any rate, we're going to do the minimum for p. So plug it in. So this is 5 times -1 minus 2. That would be -7. The 0, 1 point would be 5 times 0 minus 1, which is -1. And then the 0 minus 2 point is 5 times 0 minus -2. So that actually comes out as +2. And so our answer, our solution to this is that point. So we say the p is minimized. P is -7 when x is -1 and y is 2. That's the min value. All right, that's it. Hope this review helps, and thank you for watching.